As a concrete example, let's try to solve the following, the first order differential equation. Say y prime is equal to x plus 1 over y squared, right? That you can rewrite it, okay? By the multiplying the equation through by the y squared times the dx, you are going to get y prime dy is equal to x plus 1 times the dx, right? Now the variables are separated really. Taking integration on both sides, one of the antiderivative of y squared, that is a y cubed over 3, right? Antiderivative of x plus 1, that is the x squared over 2 plus x, right? Okay. Then we should add one integral constant. I will call it y c sub 1. Okay. So you get, by multiplying 3 on both sides of this equality, you are going to get y cubed is equal to 3 times x squared over 2 plus 3x plus 3c1. Okay? So you can solve this equation even for y. So y is equal to, okay, cube root of 3 times x squared over 2 plus 3x plus 3 times c1. Okay? And where the c1 is an arbitrary constant, then 3 times c1 is another arbitrary constant, which we may call by c. Okay? So finally we get y is equal to cube root of 3x squared over 2 plus 3x plus c. Okay? This is a general solution of given differential equation down there. Okay? It's a very simple process. Okay? Another example. Now let's try to solve the initial value problem. Say y prime is equal to y minus 1 over 2 minus x, and satisfying the initial condition y of negative 1 is equal to 2. Okay? Then again, rewriting this equation into the following form. Okay? 1 over y minus 1 times the dy is equal to 1 over 2 minus x d of x, right? Now the variables are separated here. Okay? Integrating both sides, okay? From the left hand side, antiderivative of 1 over y minus 1 is log of absolute value of y minus 1, right? Likewise, antiderivative of 1 over 2 minus x is negative log absolute value of x minus 2, right? Then you need to add one integral constant, say c sub 1. Okay? Okay? Then, solving this equation for this absolute value of y minus 1, you will get absolute value of y minus 1 is equal to e to the this expression, right? Okay? This expression down there, okay? Which is the same as e to the c1 times e to the negative log absolute value of x minus 2, right? How about this second expression down there? Okay? Can you see that this is the same as, okay, 1 over the absolute value of x minus 2? Because we have, I think you know that e to the log of x is equal to x, right? Okay? Okay? So e to the negative log of absolute value of x minus 2 is the same as 1 over square root of 1 over absolute value of x minus 2, right? So together with this part, you will get e to the c1 over absolute value of x minus 2. Okay? Let's call this e to the c1 to be c2. Okay? Then c2 is an arbitrary positive number because exponential of any real number is strictly positive, right? Okay? So here the constant c sub 2, this can be arbitrary positive number. Okay? So we have this expression, absolute value of y minus 1 is equal to c2 over absolute value of x minus 2. Right? Okay? Now let's try to remove the absolute value sign. Okay? Then we are going to, we are going to get, removing this absolute value sign, we will get y minus 1 is equal to plus or minus C2, 1 over x minus 2, right? Okay. By removing this absolute value sign, we have two different choices of the signs, plus or minus, right, in front. Okay. Now let's write the C to be plus or minus C2. Since C2 is a strictly positive arbitrary number, plus or minus C2 can be arbitrary non-zero real number. Okay? That we call C. Okay? So finally we get the expression y minus 1 is equal to C over x minus 2, where C is an arbitrary non-zero number. Okay? Let's check some exceptional case when C is equal to 0. What happened to this expression when C is equal to 0? If C is equal to 0, the right-hand side is equal to 0, so that y must be equal to identically 1. Okay? And y is equal to identically 1 should satisfy the given differential equation, as you can see from here, right? Okay? Let's remind you our original differential equation. Y prime is equal to y minus 1 over 2 minus x, right? So now I claim that y is equal to identically 1, which we obtain by setting c is equal to 0 in this expression, right? This is the trivial solution to this problem, right? This differential equation, okay? So that means what? In the expression 4, c can be really arbitrary real number, including even 0, right? Okay? So that one parameter family given by this expression 4, including the 0 for c, with really arbitrary constant c, is the general solution of the given first order differential equation. Okay? Now let's consider the given initial condition, which was the y of minus 1 is equal to 2, right? Okay? So from this expression, right, okay, you have the general solution y minus 1 is equal to c over x minus 2. Okay? Then using the initial condition y of minus 1 is equal to, right? Okay? Plugging those values, then when x is equal to negative 1, y is equal to. So 2 minus 1 is equal to c over minus 1 minus 2. That is equal to c over negative 3. The left-hand side is equal to 1. So what does that mean? C is equal to negative 3, right? Okay. So you can see that, right? So the solution to this initial value problem will be y is equal to negative 3 over x minus 2 plus 1. Okay? This is the solution to this given initial value problem. Okay? It's a very simple process, right? Okay?